Welcome everyone. So today we are going to discuss the next topic in the subject CE 405 Environmental Engineering 1 Module 4. So today's topic is loss of head in filters. So what do you mean by loss of head in filters? We know that as the filtration proceeds, there will be an increasing amount of pressure in the filter unit, which we call as the head loss across the filter, and this is required in order to force the water through the filter or to allow the water to get filtered. And this head loss has to be measured continuously because this is needed to determine when the filter has to be backwashed or when the filter media has to be cleaned. So for this reason we have to continuously measure the head loss through a filter, and this is done by using a piezometer which is connected to the filter above the media and the effluent line. So here in the figure you can see a piezometer that is connected. So piezometer, I am sure you all would have heard this term piezometer. It is a device which is used to measure the pressure, and the principle is that whenever this is connected to a pipeline or anything, what happens is it is usually used to measure the pressure in a liquid. So what happens is the liquid will flow against gravity and rise in the tube, and based on this height we can determine the pressure. That is why we use a piezometer. Now also we can say that a head loss, it just means the loss of pressure across the filter, and as a filter will become more used, or as we use this filter unit for a long time, what happens is the debris or the particles that are present in water will be arrested by the sand particles or the filter media. So these debris will plug up, and then what happens is the pressure drop will increase. And also the faster you run water across a filter, what happens is the less effective it will be and the greater the drop of pressure will be. So whenever a cleaned bed or after backwashing, whenever we put a filter back into operation, the loss of head through it will be very small, and usually it is of the order of 15 to 30 centimeters. And as the water will be filtered through the filter, like I told you, the impurities or the debris will be entrapped by the filter media, and because of this the loss of head will keep increasing. Now the loss of head, it can be measured, like I told you, using the piezometric tubes, like it is shown in this figure. Now as the thickness or the depth of the suspended matter on the top of the sand bed increases, so when the water keeps passing through the filter media, the debris or the suspended matter will be entrapped or arrested by the filter media, and the thickness of or the depth of this matter will keep increasing on the top of the sand bed or the filter bed. Now what happens is then the head loss will be increased. There will be a stage at which the frictional resistance will exceed the static head above the sand bed. So, and it is at this that the lower portion of the media and the under drainage system will be under partial vacuum, or we can call this as a negative head. So within the sand bed or within the filter bed, the head will become negative when the loss of head through the overlying bed depth exceeds the static head. So this is when a negative head or a partial vacuum will be created, and then water will be sucked through the filter media instead of being filtered. So instead of filtration occurring, what happens is when the negative head develops, the water will be sucked by the filter media. And as shown in this figure, the negative head is actually the fall of the liquid level in the piezometric tube. So you can see here the liquid level in the piezometric tube has fell below the center line of the under drainage system. So you can see the under drainage system, that line represents the center line of the under drainage system, and due to the development of a negative head, what happens is the liquid in the piezometric tube will fall below this line, that is below the center line of the under drainage system, and due to the formation of negative head, there will be the dissolved gases and the air which will be released, and that will fill the pores of the filter and the under drainage system. Now then what happens is then the filter will become airbound, and the head loss also will rise sharply, and the filter output capacity will drop. So then the rate of filtration also will reduce considerably. So Then also in the case of a rapid sand or rapid gravity sand filters, the permissible head loss is between 2.5 and 3.5 meters, and the permissible negative head is between 0.8 to 1.2 meters. So the filter, the running of the filter or the operation of the filter will be stopped or ended or terminated when the limits will exceed these values, that is the head loss between 2.5 and 3.5. So if it increases beyond this, or the negative head, that is between allowable is between 0.8 to 1.2 meters. So if it exceeds above these limits, what happens is we will stop or terminate the running of the filter. And under normal conditions, the frequency of the filter also between 2 to 4 days. So within 2 days or 4 days, the backwashing has to be done. So whenever the filter run will be terminated, as the head will increase the limits that I've mentioned earlier, what happens is we have to go for a backwashing again. So this is called as a loss of head and negative head in a filter medium.